Hi guys, today I'm going to be showing you my 2 by 72 inch belt grinder that I made myself here in my own shop. I was encouraged by seeing other people's videos and on YouTube, different places, to try and attempt this myself. I'm not a professional machinist or welder. I made this with simple tools in my own house, a 4 by 36 inch bench belt sander, and I have a 100 amp stick welder. So I know how to weld, but I'm not crazy great at it. I just get things to stick together. So I'm also a really big proponent of upcycling, recycling, repurposing, whatever you want to call it. So I reused a lot of different things in my machine, and I would like to show it to you right now. I started making knives recently, and I realized if I was going to continue to do this, I needed a way better machine than what I was using. 2 by 72 seemed the way to go, and so that's what I decided to build. Let me just give you a look. There's some really innovative things, I think, creative things that I've done on my machine that I would like to show you, so that in the event that you attempt this yourself, you might incorporate some of them and be able to make a machine on your own that you can work with and use also. So here, without saying any further, let's get to the machine. So there it is right there. The first thing that I wanted it to do was to be portable. And so I put wheels on the back of it that came from the treadmill that I scavenged the motor from. I'll tell you a little bit more about that in a minute, but as you can see, I can pick the whole thing up. It's quite heavy, but I can move it around fairly easily in my shop. I want to be able to move it around and use it in a variety of different places and settings. So the other thing that I wanted to be able to do was I wanted to be able to sand on this big wheel here, or on a wheel, on a round surface, and I also wanted to be able to work on a flat surface, or this platen that's back here over here. I was able to, so to that end, I built a machine that allows me to flip this in different directions. The belt comes off very easily. I can loosen this handle right here, and then the whole assembly, the wheel hub, flips 180 degrees, like so, and I can tighten this down again, and then I'm sanding on a flat surface over here. My tool rest comes around over here, locks into place, tightens right up over here, and I have a great surface to work on right there as I'm sanding and working on whatever it is that I'm grinding. Mostly what I'm doing is making knives, such as you can see here. I'll show you that in a minute. And this jig that I have the knife in is also something I saw somebody else build, and then I modified it and fixed it so that I can hold the blade and move it very smoothly and easily across the wheel back and forth. That's a total aside, something maybe you're not interested in if you're not making knives. So a couple of the things that I think are innovative on this machine that I would like to show you. The first is the main support, the main structure of this of the machine. This whole piece right here is a bumper, an old rusty bumper that I scored off of a dumpster at the local Ford dealer that's now out of business. There it sat waiting for me. It was the perfect thing. I went scavenging. I found this bumper. I got some 2-inch by 2-inch, 1/4-inch wall thick square steel stock, and I made this frame out of that. This is a piece of angle iron on the very bottom that forms the cross member. The back piece I actually took from the treadmill, and the wheels I replaced to suit the machine, but that wheel assembly came off of the treadmill that I scored. This motor right here is a 2.2 horsepower DC engine motor that I took from the treadmill. I wanted the treadmill motor because it's variably adjustable in speed. I'll show you that in just a moment. When I was building this, I had a hard time getting the motor to run properly, and I did all kinds of internet searches. And let me tell you, there are a lot of guys out there, really smart electrical engineer types with, potentiometers and pulse width moderators and all these different things that all I really needed was to keep the configuration of the flywheel on the end, which has the speed sensor on it, in the same location in conjunction with the controller board from the treadmill. I'll show you how I did that in a minute, and then I was able to get it to run perfectly fine, and I can adjust the speed, ramp it up, or slow it down. I didn't have to change anything. I wanted to use the same controller from the treadmill. I couldn't figure out why I wouldn't be able to do that, and I did figure out how to do that. It would have been a lot easier if somebody had just said, oh, dude, just keep it in the same configuration, make sure that maybe I'm just stupid, right? And I didn't realize what the deal was. But once I figured that out, It works awesome right now, and I'll show you that in just a second. So this is a bumper that I repurposed. I welded up this platform for the motor to sit on. I welded up this here. I put this little hook here that you can see that holds my my work platform. I have a different work table for the flat grinding and for the round grinding. When I'm using the wheel, I almost never use this. It's not really necessary, but I do have it just in case I ever need to use it. I was able to recycle and repurpose a lot of parts from the treadmill itself. So this aluminum table that you see here with this buffer on it, I put a buffing station right there, the control panel and board that you see right there, and all the support and everything that comes from that, as well as these cross members down below, all came from the treadmill because it was a heavy-duty Precor treadmill, and I was able to use a lot of stuff from it. I wanted everything to be tight and clean. There are no wires hanging around. I wired everything through the frame so that all of my wires pop out in the back over here, and it's all nice and neat and tidy. This is the controller that I told you that I needed to have at a certain distance from the flywheel over here that has a speed sensor on it and tells the control board how fast the engine or the motor is going. Obviously, you can't ramp the motor up or down if the controller doesn't know how fast it's going now, and what I found is it would just stop. It would run for 2 seconds and then shut down because there was nothing telling it how fast the motor was actually going. So some of the other design features that I think were a little bit innovative was these wheels that you need for the belt to run around on. They sell them in a variety of different places. There are supply houses out there and people that make grinding machines and parts, but those are all expensive. So I put my thinking cap on and said, hey, what can I repurpose? And I had a skateboard laying around. I have an old skateboard. You can see it up on the wall over there. My wife forbade me to use that because she's got sentimental attachment to it. But I got the idea, and I went and I ordered skateboard wheels and bearings and trucks. I was able to use the skateboard wheels. They're the perfect 2-inch width. They're about a little bit over 3 inches in diameter, but they're perfect for grinding for what I needed to do. I'm going to change this assembly. I'm making another assembly where it will give me an 8-inch, a 6-inch, and a 4-inch wheel that I can work on also. So I'll be able to grind tighter, more shallow or deeper hollow grinds on blades. To adjust the belt tracking, I took one of the skateboard wheels. I used my 36 by 4-inch belt sander, and I just slowly turned that down so that it's domed. It's not flat and straight anymore, but it's domed. You probably can't see that in the video. Maybe as I spin it, you can see it a little bit. But now, and then I used the truck. I built this assembly and welded it up so that mounts the truck there with a threaded rod that is back here, and I can turn that threaded rod with that black handle, and that moves the truck up and down like this, and I can adjust the tracking of the belt on the wheel by that, and that works awesome. So it's spring loaded. You can see the tension comes up like this and then holds against the belt and puts the tension that I need to on it. So what I'll do is put a belt on right now and show you how the whole thing works, and I'll be done. Hold on 1 second here. I'll loosen that a little bit, take that out of the way. I'm going to have to adjust the tracking when I go from, I turn the power on just as if I were to use the treadmill. I have to program a few things because I'm repurposing the treadmill, but then away we go. I'll show you the tracking system in just a minute and how I can move it back and forth. So this is cranking right now at like 4, well, if I put it up to about 5, what the treadmill controller says is 5 miles an hour, I find it works great. It's an awesome grinding speed. It's not too fast, but the advantage of being able to slow it down is when I get closer to finishing the blade and polishing, I can really grind and take a lot of material off or be very gentle and not heat the metal up too much. This particular blade that I've been working on is just out of heat treating, and I'm all set and ready to go with my final finishing grinds on it so that I can really shine it up and polish it It's 154 cm. That's been, I cryoed it at minus 91 degrees after I heat tempered it at 1940 degrees. And then I tempered it twice. So it's got right now at a Rockwell hardness of 61. It's going to be an awesome knife and blade when I'm done. I can maybe I'll show you a little bit up close. I don't know if you really want to see the blade itself, but I'll just show you what it's looking like a little bit. And in the jig that I made to hold it in place, which is a really handy piece of equipment. All right, so there's the machine running, and I just want to quickly show you one more thing. So this little tool holder right there is for the jig. So then I push the button, it stops it, gives me a couple seconds as it's winding down to grab the next belt or do whatever I'm going to do with it. So right now what I want to do is actually change the configuration around so you can see how easy it moves. So I'm just going to pull this out of the way. I'm going to loosen this handle here, take the belt off. This whole thing flips 180 degrees like that. Tighten the handle, pop the belt back on. I'm going to need to adjust the tracking is different from one side to the other a little bit. So I'll adjust the tracking, which I'll show you on this now as I'm moving this around, and then crank it back up. This thing cranks up to what the machine says is 10 miles an hour, and then it grinds like crazy. It's a really pretty crazy thing. So I'm just going to bring this over here like this, and I think you'll be able to see as I adjust the tracking, you'll see the belt move over on the wheel. It was moving over that way. Now I'm going to move it back the other way and off to the other side. So very simply, as I'm adjusting this handle right here, you can see the tracking moving back and forth. Just a little bit of an innovation over what I've seen that most machines do and how they work, but it works awesome. And I'm really thankful to have been able to build this. You can see the motor, the flywheel going, the stand, the whole thing. I'm not sure how much it weighs, but it's fairly heavy and a substantial piece of equipment once I got all the steel going on it that needed to be on it. So anyway, there's my 2 by 72 inch belt grinder, and I hope that this encourages somebody out there to get busy and do their own machine. It was a lot of fun building. It was a tremendous amount of fun figuring it all out and doing all the engineering. It was like putting a puzzle together. And I figure, hey, if you can grind a knife, if you can build a beautiful knife and knife handle, there's no reason why you can't do this. So I say give it a try. Thanks for looking and watching. Talk to you later. Bye.